Hi everyone, so welcome to another course where I'm going to teach you how to test ICs using the multimeter. You're going to learn all about integrated circuits. You're going to learn what is integrated circuit inputs, outputs, integrated circuit pinouts, references, circuit diagram, how to troubleshoot failed integrated circuits, and much more. So let's get started. But please, before diving into details, make sure you subscribe and click the notification bell to stay updated for future videos like this one. So we're gonna discuss integrated circuits in laptop or computer motherboards, into tablet motherboards, cell phone motherboards, routers motherboards, and other devices motherboard. So the purpose here to study many motherboards is to understand 100% all about integrated circuits and how you deal with integrated circuits using the multimeter. So let's dive in. Of course, we're gonna also use the circuit diagram in order to understand the hardware parts, okay, and the soft parts. So first guys, let's take a look to integrated circuits, an overview about integrated circuits in the motherboard. So for integrated circuits, as you can see, are the big ICs in every motherboard. Okay, so basically my videos are for beginners, intermediate level and advanced level. That's why sometimes I teach you some basics. So for advanced and intermediate persons, don't panic when I explain some basics, because also beginners matter. And more than 60% of my followers are beginners. Okay, so as you can see here, always the big component here are ICs, like this one for example. This is the Super I/O IC. Here, as you can see, this is basically the laptop motherboard. Here we have the clock generator IC. This is the BIOS IC, and over here this is MOSFETs. So do you see, as I told you before, okay, so the BIOS always is bigger than the MOSFET in terms of size. And over here we have chipsets, as you can see. So the same working principle in every motherboard. For example, this motherboard is for tablet, as you can see. Here we have, as you can see, this is the ROM or the BIOS. Here we have the CPU, here we have the RAM, and over here we have the power IC, as you can see. Do you see? Always any IC you will find ceramic capacitors around it. As you can see, the same also for, this is basically the cell phone motherboard. As you can see, we have ICs over here. Okay, so the same working principle, and as I told you before, we're gonna study this. Always you will find ceramic capacitors around the ICs. I'm going to teach you why exactly and how we can use this ceramic capacitor to detect whether the IC is good or not. The same also for the router. As you can see, here we have IC, the processor over here. Here we have another IC, we have ceramic capacitors. Here we have other ICs. This is basically the RAM. Okay, so we're gonna study all this. So first, let's discuss how to identify the pin number 1 of the IC. So always you will find for any IC, as you can see, a hole over here. Do you see, for example, for this, we have this hole over here. We have those here, but this is the hole. That means this is the pin number 1. Or we have this triangle, as you can see here. So this is pin number 1, pin number 2, 3, etc. For this IC, for example, this is basically the BIOS. Do you see? We have a hole over here, and we have this mark, means this is the pin number 1, 2, 3, etc. The same, for example, for this IC, we have this hole here, and also this mark here, means this is pin number 1, tertiary, etc. And for this IC, as you can see over here, this is basically the audio control IC that controls this probe, as you can see, for audio, that controls this connector for audio, as you can see. So this is the audio control. When you find, for example, those connector or ports are not working, means you have problem with this IC. I will show you how to test it and to fix it. Do you see? Anyway, here we have this hole, and this mark here means we have the pin number 1, 2, 3, and so on. The same for this one. We have the mark here, okay? So if we go to tablet motherboard, as you can see, the same working principle. We don't have a hole, but we have this point. This dot here means over here we have pin number 1. The same, for example, for this processor, we have a dot here, okay? The same here also we have here dot, okay? So for the seal for motherboard, as you can see, we have the same working principle. Let's see, for example, this IC. As you can see, we have the dot over here. You see this dot means this is the pin number 1. And as I told you, always we have some capacitors around the IC. Here also we have the dot over here, means over here we have pin number 1. So for the router motherboard, also we have a dot over here. Do you see this dot? Means this is the pin number 1. And if we go here to this chips, this is basically the RAM, we have a dot over here and a dot over here, means this is the pin number 1. And over here, as you can see, we have a clear IC, as you can see, where we have the dot here, do you see? And over here we have 1. Do you see here? 1. Here we have 1, 2, 3 until 32. Here we have 32. Here we have 33, and as you can see, 64, 65, 66, 7 until 96, as you can see, and 97, 98 until 128. So this processor basically has 100, this IC basically has 128 pin. So I want to share with you here a very important tip. If you focus here, as you can see, we have this path over here, these lines. Do you see? These lines basically are not the same as this one. So this is a bolded line. This bolded line means here we have power. Here we have VCC. And those lines, as you can see here, a thin lines means this is just signals, control signals. Those also. And over here also we have control signals. But this bolded line here means this pin, the pin 64, hold VCC. So using this method, you can now do input voltage for every IC without the schematic. So do you see for this IC, for example, here we have many lines and paths. This is basically for control signal. Do you see? A thin lines. And over here we have a very bolded line. This line, as you can see here, this is ground. This is not input voltage. This is ground. Okay? And over here we have control signal. So here do you see this bolded line, and this also connected to the ceramic capacitor. So this is the input power over here. And here, as you can see, this is the ground. Okay, do you see the ground? So the ground is connected to the IC in this pin. In this pin also, as you can see, all these are ground. And in this pin also we have ground. This is basically ground. If I put one probe of the multimeter here and another probe in the ground, I will get a buzzer, a continuity. Okay, so this is how I can know whether the pin is connected to the ground or to power rail or is just an enable signal. So guys, if you understand this trick, you can analyze any circuit or IC. So let's see, for example, this MOSFET, as you can see over here. So this pin, as you can see, is connected to this line. Do you see this line? It's a thin line, but this pin is connected to a bolded line, as you can see. So means this is the gate. Why the gate? Because this is the control signal, a thin line. And this one, this is basically the source. Do you see the bolded line? And here we have the drain. So the power is passed from this terminal to drain to source, as you can see. And here we have the gate, as you can see. Do you see the gate? So this MOSFET also, I can even know the control IC. So this IC control this MOSFET, as you can see, because we have this line coming from here. Okay? So let's see another. So here we have a clear example, guys. Please pay attention. Do you see here? We have source, 3 terminals connected together. Do you see? This part means all these 3 terminals are connected together. And we have the gate. Do you see the control signal? Do you see this part? That I can follow until I find the source. Okay? So this is the gate. This pin receives just a control signal. It could be 1 volt, 2 volt, 1.5 volt, etc. etc. But here we have the source, as you can see. And in the other side we have the drain. We have another IC, a clear IC, as you can see. Guys, this is basically the pin number 1. Here, do you see in this pin we have a bolded line, means here it gets input voltage, the power in. And over here, do you see the signals? This is just a signals, enable signals and control signals. And over here also we have a bolded line connected to this hole, means over here we have ground. So this pin is for ground, as you can see here. So this pin is for ground, this pin is for power, and those are just signals, control signals. So as you can see, the power pin is connected to ceramic capacitor in order to be filtered. So always the power pin is connected to the ceramic capacitor. Do you see, guys? I can know about all pins without the schematic. So here I have another example. Do you see? This is basically an IC, not MOSFET. Here we have a tin pin. Here we have a tin pin. Do you see a bolded line? Means this is the input power. It could be 5 volt. And over here we have, as you can see, tin path, as you can see here. If we go here also, we have a control signals here, and we have this bolded part connected to this hole, as you can see, means this is the ground. This pin is for ground. This pin is for input voltage, for VCC. Why? Because we have here the bolded line. So this is a secret that you cannot find everywhere, just in my channel, in electronic repair basics. So please, because you find like these tricks and secrets, please hit that like button. I want many likes for this video if you like really this exclusive content. And remember that your support is what keeps me going. So do you see also the audio control IC, as you can see here? All these are just control signals, as you can see. We have control signals and we have extensions, as I told you before in the previous video, okay? And you will find usually all pins of the pins of any IC are connected to ceramic capacitors or resistors. That's why, for example, here, let's look for the power where we have the VCC here, as you can see. Do you see the bolded line? This bolded line means we have VCC here. The VCC is connected to this ceramic capacitor. Means if you don't find here VCC, you should check this ceramic capacitors. Is it good or not? Because this is the capacitor that feeds this IC with the VCC or the input voltage. So also in the circuit diagram, you will find the same working principle, as you can see. Do you see over here? This is a bolded line. So this bolded line basically means we have a high voltage over here. And those lines, as you can see, means just a signal, a low voltage. So if you pay attention here, so let's see here, guys, we have a note in the schematic here. Do you see? This line means a high power trace, 19 volts. So let's see an IC, for example. Let's see this IC over here. Do you see here? We have this line over here. This is a bolded line. We have the V voltage, the V reference. And over here we have this line, for example, this is for compensation. This line, this is just enable signals. And for the voltage, we have this bolded line, exactly as the IC. Control signals lines, and we have this bolded line means the power for the IC. Exactly as we have in the motherboard, as you can see. So these thin lines is for just enable signals, and the bolded line here is for power, as you can see. So here, for example, if you don't find here, let's assume that the power here is 5 volt. If you didn't find here 5 volt, you should go and check this capacitor. Is it good or not? Now I'm going to teach you how to test an IC. I will give you the exact way and the final way to test any integrated circuit in the world. I will explain to you the methods, basically the 3 methods that you can use to check the IC. So the first method is, so let's get started. So here we have the IC, guys, that we gonna study, as you can see. Okay, so here we have the IC, guys, that we're going to study, as you can see. So please pay attention. If you understand what I'm going to say right now, you can understand, test and fix any IC you have. So let's get started. So basically over here we have the IC, the integrated circuits. And as I told you before, always around the integrated circuit you will find many components, especially ceramic capacitors. So for the ceramic capacitors, there is 2 kinds of ceramic capacitors: power capacitors and data capacitors. For power capacitors are the capacitors that feed the IC with the voltage, like this one, for example. Do you see this one? Here we have a bolded line, means the input for this IC is from here. So this pin of the IC is connected to this capacitor. As you can see, we have the path here, and the other terminal of capacitor connected, as you can see, to ground. We can even check using the multimeter. So let's put the multimeter to the continuity option. As you can see, let's check. The continuity option is set correctly. So if I put one probe here, as you can see, and the other probe in this terminal, do you see? So this ceramic capacitor is connected to the IC in this terminal. But in the other terminal, this capacitor is connected to the ground, as you can see. Do you see? Why? Because we have this path over here, connected to ground. This is ground, basically. So all capacitors around the IC, you will find it connected to the IC in one side and to the ground in the other side. Let's check this one, for example. This ceramic capacitor also, as you can see, this pin is connected to the ground, as you can see, in this terminal, and this terminal of this capacitor is connected to the IC over here, as you can see. Do you see the path? Here we have the path. The same for this one, for example. Here we have the path, as you can see. So this also connected to this IC in this path, and as you can see here, connected to the ground in this side. This one also, here we have the path connected to the IC here and connected to the ground here, as you can see. We can even check it also, as you can see. Okay, so this information right now we will use it to find a short circuit. So because the ceramic capacitors are connected to the IC in one side and to the ground in one side, and of course the IC itself connected to the ground, as you can see, in one or two of its pins. Do you see here? These 2 pins basically are connected to the ground, as you can see. Why? Because we have here this bolded path, means this is the ground. Okay, so when you want to check whether the IC is shorted or not, you can just check the ceramic capacitors. As you can see, this is good. This one also is good. This one also is good. This one also is good, as you can see. If you find any shorted ceramic capacitor in both sides, means not the ceramic capacitor is the shorted component, means the IC is the shorted component. So this is basically the second method that we use to detect if the IC is bad or not, by checking the ceramic capacitors around it. If you find that many of ceramic capacitors are shorted in both sides, means the IC is shorted. So what about the first method? So the first method is by checking the heat of the IC using your finger. If the IC is bad, you will feel a very hot, that the IC is very hot, is not normal. In that case, you should replace the IC using the same reference as you have here. The second method is by checking the ceramic capacitors around it, as I told you before. And the third method, this is basically for advanced people or for professional. Everyone that follow me in my YouTube channel will be a professional. Just a matter of time. So the third method is by checking the inputs and the outputs. Let's assume, for example, that this IC, this is the input of the IC in this pin, for example. The output, for example, is 3.3 volt. So to get 3.3 volt here, you should first receive, the IC first should receive the input signals, including here the input voltage, the VCC, for example, 5 volt. If, for example, 5 volt is missing here, impossible. We cannot get here the output. So when you didn't get the output, doesn't mean the IC is bad, is failed. No, you should go back and check all inputs. So let's make it simple in paper. So for this IC, for example, do you see this IC? Here we have the V out. In pin number 3, we have V out. Basically, V out is, as you can see, if we follow this path, the V out basically is, as you can see, the VCCP, 1.05 volt for chipsets. This is the V out. But to get this V out here, we need first inputs. So inputs, for example, like the VCC, as you can see here, 5 volt. Do you see here? We have this 5 volt is the first input. We should get here 5 volt. We should also receive power good. So the IC should receive power good. And also, as you can see here, EN means enable signals. Okay, the enable signal. Once the IC receive the input signals, okay, it will generate, as you can see here, the drive. You see here, drive, and over here we have drive. It will generate, as you can see, the drive signals to these two MOSFETs. So drive high signal to this MOSFET and drive low signal to this MOSFET, and then we will get over here the plus VCCP V out. So in order to get the output, the IC should receive first the inputs. So you cannot see here, for example, if I didn't get here 1.5 volt plus VCCP means automatically the IC is bad. No, you should check the inputs first. So remember, guys, we have IC. Okay, let's summarize a little bit. Here we have IC, integrated circuit. This is for beginners. Okay, this IC, as you can see here, has many pins, inputs, outputs. Okay, here we have inputs, and over here we have outputs. So output, for example, it will generate 3.3 volts, and also for example 5 volts. But for inputs, as you can see here, it needs the VCC 19 volts, for example. It needs also some enable signals, enable 1, enable 2, about 3.3 volts, 3 volts. Also, the IC need the power gate, okay, the power gate signal, and also other signals like V reference, and also other signals like shutdown signal. So basically this signal is to protect the IC. When the IC becomes hot, very hot, this signal will be activated and the IC will stop working. So all these signals and other signals are inputs. So if you use your multimeter and check here and you didn't find 3.3 volt or 5 volt, does not mean the IC is bad. What should we do is to check the inputs. So to check the inputs, you should first refer to the data sheet. You should have the data sheet of the IC. So this is how you can check the third method. So the first method is by checking the heat of the IC. Use your finger. If you feel that the IC is very hot, means the IC is bad. So the second method is by checking the ceramic capacitors around the IC. If you find that the ceramic capacitors around the IC are connected to the ground in both sides, means the IC is bad. The third method is by checking, as you can see here, the inputs and the outputs. If you don't have the inputs, you cannot get the outputs. So thank you very much, guys. I hope that you enjoyed the video. Please don't forget to like the video, share with other people like you, and for anyone who want to join me in my Patreon page, you are very welcome. In that page, you will find a very exclusive content. You can download laptop schematics, and of course, for anyone who wants me as a mentor, I can mentor you. I can help you until you fix your computer problems or issues you have. I can give you my WhatsApp number, but to do so, you can just go to Patreon page and be a mentorship experience member, and you are very welcome.